Okay, so I'm working through my 2007 Algebra-Based Physics final exam. I'm on my last problem, and this is a 2-hour exam. I let them, in this case, I let them pick 7 out of the 8 to solve. That way, if there's one they didn't like, they just didn't have to solve that one. Okay, so let's just get started on this last problem. Dr. Allain, that's me, is holding a 100-gram meter stick by resting it on 2 fingers. So like this. Oops. So I'm holding it like this. One finger's at the 40 centimeter mark and one's at the 90. So let's say this is 0, 40, 90. If Dr. Allain pushes his fingers together, which finger will have the greater frictional force on it? This is actually based on a trick. I want a good stick. Let's see. Let's try this one. This is a great friction trick. If I move my fingers towards each other, they meet at the center of mass, except that one doesn't work. They meet at the center of mass. Okay. Which finger will have a greater friction force on it? Why? Which finger will get to the center of mass first? Okay, so let's just draw this. This is a problem that's cool. So let's pick this as the point of rotation. And this is a rigid body equilibrium problem. So what forces do I have acting on this mass? Let's put that as a point. So the first thing is I have the gravitational force right there in the middle. So when we talk about rigid object equilibrium, it doesn't matter just what forces are acting on it, but where those forces are. So this is at the 50 centimeter mark. Now, this is a finger pushing up. So I have another finger I have this finger called F1 up, and that one's over here, F2 up. I assume those are up. Now, if I slide these in, these are actually normal forces. If I slide these in, then I could say the frictional force, F friction, is equal to the coefficient of friction times the normal force. So the one that has a greater normal force is going to have a greater friction. So let's call this point O. I know that F net Y is 0. So that's going to be equal to F1 plus F2 minus mg. So the sum of these two has to equal the weight of the stick. Fine. Now I also know that the net torque is 0. Torque net O equals 0. So the torque is equal to F, let's write R perpendicular. So I take the force times the perpendicular distance to that point of rotation, and I can use that in this case. So here's F1. It's going to be producing a counterclockwise torque, so it's going to be positive. So I'm going to say plus F1 times this distance, which is 40. Let's put it as 0.4. Now, gravity exerts a negative torque because it wants it to rotate in the negative direction. So that's going to be minus mg times 50 centimeters. And that one's going to be positive, so plus F2 times 90. And I know the mass of the meter stick. So these are my two equations, right? Both of those have to be true. Now you can see right here that the sum of these two torques has to be the torque due to gravity, right? And which one's further from the point of rotation? I guess it's not completely obvious, but I think it's not completely obvious. Well, let's just solve for these two forces. So let's solve this one for F1. I get F1 equals mg minus F2, and then I will plug that in up here, and I get mg minus F2 times 0.4 minus mg times 0.5 plus, that's a 0.9, 0.9 F2 equals 0. So if I multiply this out, okay, this is the first time I'm using more paper. I feel better. I got a lot more space. I felt constrained on all those problems. It kind of freaked. It's like equation claustrophobia. Okay. So let's multiply this out over here. I'm on this equation. So I'm going to multiply that out. I get 0.4 mg, and it's weird using these numbers, but that's fine, minus 0.4 F2 minus 0.5 mg plus 0.9 F2 equals 0. So let's combine these two terms together, and I get 0.5 F2, and then I'm going to combine these two together. I get minus 0.1 mg. Add that to the other side. I get 0.1 mg. Solve for F2. I get F2 equals 0.1 mg over 0.5. Now I can use that with my other equation. F1 equals mg minus F2. So this is going to be, this is a half. This is going to be dividing by a half. So it's like multiplying by 2. So this is going to be mg minus 0.2 mg. And that's going to be equal to 0.8 mg. Okay, so F1 has 0.8 mg. F2 equals 0.2 mg. So which one's greater? That one's greater, right? F1's greater. So which one's going to have greater frictional force? This one. Okay. And just look at the diagram. In order for, if I probably should have picked this as the point of rotation. That would have make more sense. Then you can see the torque due to these two has to be equal and opposite. So this one's closer, so it has to be pushing up with a greater force. That was easier. I didn't have to do any math, right? I should have done it that way. Okay, so which one has a greater friction force? F1. Which finger will get to the center of mass first? Well, if F1 has a greater friction force, when I push my fingers together, this finger is going to slide, right? And that one's going to stay stationary until this one gets closer, and then this one will slide. I really wish you can get a long meter stick like this and slide your fingers in, and they just rotate back and forth. Which one's sliding? It's kind of cool, but they should reach at the center mass at the same time. I did this as a demo in class, so they might just remember that. It's I think it's fairly easy enough that they could explain it without a lot of math. So I would hope they wouldn't skip this one. But that's it. That's my 2007 final exam. And one of the things that I definitely learned, and I don't know which point I learned this, it was work out the final beforehand. And if they have 2 hours to take the final, then I should probably be able to write out the solution like this in 20, 25 minutes, easy. Because I know what I'm doing. And if you don't know what you're doing, it's going to take longer. So I always do that as a test, right? And if I can't do it in a quarter of the time it takes that they have, then it's too long or it's too complicated. That's one of the things I use. So, but there you go. That's my 2007 test. I think I would write a different test now, but I have grown in 14 years, as you would expect. Okay.